to solve this by factoring, well, hopefully you understand the first thing we're going to do is factor. Now, so let's factor this. If I'm going to factor this, I put a negative 20 on top and a 1 on bottom. And we have to think, what multiplies to get negative 20 and adds to get 1?
19.
Hopefully you know that'd be 5 and negative 4. So, what I now have is x plus 5 times x minus 4 equals 0. So right there is what I now have in factored form. Now, how does this help us solve it? Well, if you have two things multiplied to equal 0, do we understand that one of these has to be 0 to make the whole thing equal to 0? So, either one of them has to equal 0. So, for this particular problem, I'm going to set each piece equal to 0 because one of them has to equal 0. So let's do the first one equal to 0. Let's do this one. X plus 5 equals 0 and x minus 4 equals 0. All right, one of those has to equal 0. So can you just look at that and figure out what would make, say, that 0? Can you look at that and figure it out?
Negative 5.
Okay, can some of you see that's negative 5? And what will make that 0? Positive 4. Now, what you're technically doing, just in case it helps to see it this way, you're technically minusing 5 to both sides to solve. So are we okay that ends up being x equals negative 5? You're solving it. Some of you can see it. Some of you might need to solve it. This one's, you're going to add 4 to both sides. And there we go. Those are my two answers. If I were to take negative 5 and plug it in right here and minus 20, I'll get 0. If I were to take 4, plug it in here and here, minus 20, I will get 0. Okay, these are my two answers. X squareds or quadratics tend to have two zeros. Now, do I have to solve these? No, a lot of you can just see in the answer. That's fine. Do you actually notice the opposite of these are always the answer? You also might notice that. Now, something I need to highlight here, I'm going to put it right here next to it, is in order to solve by factoring, it has to equal 0. If that, say like that right there was a 5 or a 6, you first have to move it over. You cannot solve by factoring if there's a number here to start with. Got it? So let's write that down. In order to solve by factoring, you first have to make it equal to 0. So you first, to solve by graphing, it first must equal 0. You first must equal 0 in order to solve by factoring. In order to solve this one, we're going to solve by square rooting. Now, in order to solve by square rooting, the first thing you want to do is get the x squared by itself. So I'm first going to do is add 18 to both sides. I now have x squared equals 7 plus 18 is 25. Now, some of you can look at that and go, oh, what squared is 25? Oh, that's 5. But isn't it also negative 5?
Yes.
Won't positive 5 and negative 5 both when squared give us that?
Yes.
So, yes, some of you can see the answer right now. But the technical thing we're going to do to both sides, in order to get rid of a square, the undoer of squaring is the square root. So what we're going to do is we're going to square root both sides. When we do that, my answer is, don't forget positive or negative. I have two answers. It could be a negative or a positive. And the square root of 25 is 5. There's my answer. So how do we know when to use the square root method? Or how do we know what to do first? The first thing you want to do is get the x squared by itself. First, you get the x squared by itself. That is a very important first step. Get the x squared by itself, and then you square root both sides. So first get the x squared by itself, then square root both those sides. Now, how do you tell the difference between these two? How do I know when I'm going to use factoring and when I'm going to use square rooting? When I'm going to use factoring is when I have an x squared and an x. When are you going to use square rooting? When all you have is an x squared. Because if all I have is an x squared, can I get it by itself? Got it? So when do we use square rooting is when we can get an x squared isolated. When we use factoring is when we can't get it isolated, and here we get it equal to 0. You must first get it equal to 0. If I'm going to solve this by completing the square, the first step is I need a blank right here. Remember completing the square, you need a blank next to the x? So could I add the 2 over? So what I'm going to do here, if I move that over, hopefully you can understand, I could just write that as plus blank, and if I move the 2 over, won't that become a positive 2 over here? Now, so what I did is I moved the 2 over, and I put a blank there, and I put a blank over here. Now, you might get confused that I have a plus here and a plus there. Because before, didn't we have a plus and a minus? Now, think about that for a second. Why do I actually have both pluses? What's in the middle of here? An equal sign. If you have an equal sign and you're solving, aren't you supposed to add a number to both sides to keep it balanced? When we were converting functions, you had to add and subtract the same number because it was all on one side of the equal sign. Since these are on opposite sides of the equal sign, they're both pluses. If they're on the same side of the equal sign, one's a plus, one's a minus. That step right there is going to confuse you a little bit and mix you up, and you do the wrong one at the wrong time. You got to be attentive to that. But here we're adding to both sides. With that said, how do we figure out the blank? Well, do you guys remember you take 6 here? And what do we do with it?
Divide by 2.
Yep, you divide by 2 and you square it. What do we get? Take 6 divided by 2 and square it. What do we get?
9.
You get 9. So you're going to add 9 here and add 9 here. That is okay because they're on both opposite sides of an equal sign. Okay, can we factor the left side? If we factor the left side, won't there be 9 on top and 6 on bottom? We're factoring the left side. We're factoring this right here. What are my two sides going to be? It's 9 on top, 6 on bottom. What are the two sides?
3.
They're both 3. Now, with complete the square, do you guys remember they're always the same on the sides? Now, right here, won't this be x plus 3, x plus 3? Can we jump, just hopefully you can jump to this. Can I simply just put x plus 3 squared? Instead of putting x plus 3, can I just put it right away as squared? Because we kind of hopefully getting used to that it's always going to be the same. What's the right side going to equal? You hopefully see that as 11. All right, so we had to complete the square and we got to here. So how do we finish this? How do you get rid of a squared? What's the undoer of squaring? It's called a square root. So can I square root both sides? When I square root both sides, I end up with x plus 3 equals positive or negative square root of 11. Okay. So I just square rooted both sides. I got to here. How do I get x by itself? How do I get this 3 off the x? Oh yeah, can't we just minus the 3 over? Now when I minus the 3 over, do you want to put it behind or in front of the square root of 11?
In front.
It usually is put in front, because if I put it behind, would you think it's maybe inside the square root? So my final answer is going to be x equals, I have the negative 3, positive or negative square root of 11. That is my final answer. So just remember, when you do completing the square, when you get to here, you square root both sides and finish it off. Now, completing the square is not good a lot of times. When completing the square is really good, just you guys, is when this is even. If that number right there was odd, stay away from it with a 10-foot pole. Run far, far away. If this is an odd number, do not try completing the square to solve something. It's a bad choice. Because you'd get odd numbers. And then you'd be adding, when you get odd numbers there, you get half fractions, and you're dealing with tons of fractions. It's nasty. The second thing, when we know completing the square is a good option, is that's even, and a lot of times this number is really big. Let's say that was 200 right there. Factoring and all that kind of stuff would suck. Quadratic formula, which we're going to learn, wouldn't be very good with a huge number. So completing the square is good when that's even, and this number right here, or the number over here, that C value, is kind of a large number. When we use quadratic formula, you need to first understand that A is a number in front of x squared, B is a number in front of x, and C is a number by itself. You need to be able to spot your ABCs. It also has to always equal 0. So is this problem already equal to 0? Yeah. So can we find my ABCs so we can plug them into this formula? Yeah. Okay, my A. Well, my A is a number in front of the x squared. So since there's nothing there, are you okay there's 1x squared? Since there's no number in front, that means I have 1x squared. My B value, so what's in front of the B? Sorry, the x. Are you okay that B is 3? And C is a number by itself, so what's C equal to? The -5. Can you take each of those numbers and plug them into this formula? And then the problem with this formula is simplifying it down. Usually the square root's the hardest part. So here we go. This one kind of is an easy one. But as we plug this in, you get x equals the opposite of B. So B was 3. Then we got a plus or minus the square root of B squared, so that'd be 3 squared. I'm just following the formula. Minus 4 times A was 1, times C, which is -5, all over 2 times A, which is 1. So that right there is the starting point. We find our ABCs, we plug them in. Again, make sure you have it in standard form first. Now let's start simplifying. So I have x equals, well, the opposite of 3, is everybody okay with -3? Then I have a positive or negative. Then what's 3 squared? 9. And then this one, when we multiply -4 times 1 times -5, let's multiply all 3 at once. -4 times 1 is -4. -4 times -5 is positive 20. And 2 times 1 is 2. All right. The only thing left is the square root to simplify. So x equals -3 plus or minus the square root of, what is inside of there? 29 over 2. Now the reason I'm done is, does 29 have any squares in it? Actually, it's prime. It doesn't have anything in it. But if it had a square, we would break down the square root. All right, something to be aware of. What if that 29, say, was a 25? If that was 25, could you make that a 5? Could you then go -3 plus 5, which is 2 divided by 2, get 1? Could you go -3 minus 5, -8 divided by 2 is -4? So if that's a nice square root that breaks down, let it do it. Let's say that right there was 24. Couldn't you break down 24 to be 2 square root 6? The square root of 24 can break down to 2 square root of 6. So sometimes these square roots can simplify. What if that was a negative 29? Wouldn't you put an I out front? Make that I square root 29? So that square root can do a whole bunch of stuff. Sometimes those square roots are nice, perfect square numbers. Sometimes that square root is a negative. Sometimes that square root can be broken down. Here's a weird one. What if that square root was 0? It's just negative 3 over 2. You got nothing. So that square root can be kind of tricky, and that changes how the answers look. Quadratic formula always works. It's not very good if your A, B, or C are really big numbers. It's not your best choice. But if A, B, and C are all like single digits or kind of low numbers, it's not a bad idea to try it. This last way of graphing, solving by graphing, look carefully. If I wanted to solve this, could you use quadratic formula, maybe complete the square, maybe factoring or something? Could I move these two over and get it equal to 0? But why? If we did it by graphing, watch how easy it is. If I graph this equation, it's right there. See the parabola? See the y-intercept's negative 3? See how it hits negative 3? See the a value is 1 over 1 up 1 over 1 up 1? This is actually the graph of the parabola. And look at this right here. Isn't that the graph of the line? If you simply graph both sides, watch what happens. The answer to this is where they cross. So the answer is simply going to be that right there and that right there. So x equals negative 2 and 1. Done. So if you had a graphing calculator that graphed it for you and had this sitting there, it is a really easy answer. All you're looking for is where they cross. The x values of where they cross are the solution to this problem. If I wanted to solve this one right here, what happens is, most likely before you got this table, sometimes they'll just give you a table and say what would the solution be, which doesn't make a lot of sense. So let me actually give you the equation that goes along with this table. The equation that goes along with this table is f of x equals negative x squared plus 2x plus 1. That would be the equation that goes with this table. Now, if I wanted to find the zeros of this, okay, actually, let's take that back. Let's just, instead of putting f of x, let's just call that 0. The graph is f of x equals. That is the graph of this table. But if I had the equation 0 equals negative x squared plus 2x plus 1, to solve that, we can use this table of the graph. I can solve this equation right here. Since this is the equation that gave this table, I can use this table to solve it. Because, do you guys understand that to solve this, what we're looking for is where this graph crosses the x-axis? We want to know where it's 0. Got that? We're trying to find out where is this equation equal to 0. It's where is this graph cross the x-axis. It's different from this one. This one, you had two separate equations. Graphed them each. This one, you're wondering to know when this equation equals 0. So let's look at the graph. Where on this table does it have an output of 0 or about? Between what values will this cross the x-axis? Now, if you were to take the time to sketch this, you could kind of get the idea. If we sketch this, you might get a better view of this. Let's plot some of the points. I have negative 1, 2. I have 0, 1. I have 1, negative 2. I have negative 2, 1. Do you guys see a parabola? Can you see that parabola? I just plotted the points. You could do that. Couldn't you just plot these points on a graph, and now can you see where this is about where it's crossing the x-axis? Can you see about where it's crossing? Can you see a parabola right here? can kind of see a parabola going like this. So can you approximate your x-intercepts? To solve this, we're looking for x-intercepts, zeros. Now, I did all this work. You could technically just look at it. Can you tell, hopefully, that somewhere between these two numbers is going to cross the x-axis? And somewhere between these is going to cross the x-axis. How did I notice that? Well, doesn't it change from negative to a positive value? And a positive to a negative value? If you're looking at a table, and when you want to know when it crosses the x-axis, you're looking for the values of when it changes signs. So my answers are somewhere between -3 and -2 and 0 and 1. So here's my answers. My answer is going to be x is equal to -2 point something. I don't know what that something is. 2.4, 2.5, 2 point something. And my other one's going to be, let's go 0 point something. Isn't it between 0 and 1, isn't that point something? And here, isn't it going to be -2 point something? Whatever I don't know the exact values, but I know it's going to be 2 point something and point something are the two values where it crosses the x-axis. So the solution to this equation is something like that. If we had a multiple choice test, look for the ones that are best in there, that most approximate it. That's what we're doing.